or in this module, you are going to learn or explore to the concepts of DC to AC conversion. So DC to AC conversion is known as inversion operation. You know that converter is a circuit that converts AC voltage from one form to another form. Either you can change the magnitude of voltage, or you can change the frequency of the voltage, or you can change average value of the voltage. Based on the type of operation what you are going to perform, then we are calling that circuit with a different name. So the DC to AC converters are known as inverters. DC to AC conversion operation is known as inversion. It is called inversion because it is an action that was in principle opposite to the operation of rectification. You know that rectification is the process of converting an AC voltage into a DC voltage. So inversion is the process of converting a DC voltage into AC voltage. A DC voltage into AC voltage. But the problem with these inverter circuits is that the output that is available across the load terminals of this inverter circuit is not pure sinusoidal. It's not a pure sinusoidal one. That is the problem with this inverter circuits. But we see how to convert that voltage that is available across the output terminals of these inverters into a sinusoidal one. That is a different case. Okay. But the output that is available across the terminals, output terminals of an inverter is an alternating quantity. An alternating quantity. In general, these alternating quantities are represented with the help of a sinusoidal voltages or a sinusoidal functions, but an inverter circuit never gives a sinusoidal voltage across its output terminals. So, what it will give? It will give a square wave or quasi-square wave across the load terminals. First, what are DC to AC converters? So, DC to AC converters are the power electronic circuits with AC output voltages are referred to AC to DC, DC to AC converters. So, these are the power electronic circuits with AC output voltages. Power electronic circuits with AC output voltages and are referred to as DC to AC inverters. DC to AC inverters are also known as static inverters, uses fixed DC sources to provide symmetrical AC output voltage at fixed or variable frequency or magnitude. So what is the AC to DC to AC inverters will do? They use fixed DC sources to provide a symmetrical AC output voltages. It will provide a symmetrical AC output voltage at fixed or variable frequency. So it will provide the symmetrical AC output voltages at a fixed frequency or a variable frequency. It means it is possible for us to obtain a fixed frequency AC output voltage or a variable frequency AC output voltage, or it is possible to have a fixed magnitude at the output terminals. So the output AC voltage system can be of single phase or three phase. Depending upon the load requirements, we can obtain either a single phase or three phase voltages at the required frequency. In general, these DC to AC converter circuits are used to obtain power frequency voltages. Power frequency voltages. So what are the power frequency voltages? The voltages that are having a frequency of 50 hertz or 60 hertz are known as the power. In sometimes in variable voltage frequency applications, this voltage may slightly go up to 10 times of the power frequency voltages. That all depends upon the type of the application. In general, adjustable speed drives in which AC drives are involved, in such cases, variable frequency inverters are used. These variable frequency inverters are used in adjustable frequency, adjustable speed AC drives. You know, AC drive or will run at a constant speed. Their speed can be changed or varied only by varying the frequency, only by varying the operating frequency. So, to have a very speed AC, you need to change the operating frequency of the drive. For such cases, these inverters are best suitable. Inverters are best suitable. So, these inverters in commercial, for domestic applications, these inverters will operate at a frequency range of 50 to 400 hertz, and in general, they are manufactured to produce the voltages having magnitudes in the range of 110 to 380 volts AC. Akada hyphen undali. Okay, it was a mistake. So these are designed to operate or designed to give a voltage magnitude ranging from 110 to 380 volts. So these inverter circuits are used to deliver power from a DC source to a passive or active AC load, or with the help of a conventional SCRs or gate turn-off thyristors or insulated gate bipolar transistors IGBTs or metal oxide semiconductor field effect transistors. That means in the inverter circuits can be realized by using any of these devices, SCRs, ZTOs, IGBTs and MOSFETs. The problem with using SCRs is that SCRs require a separate commutation circuit to turn off the thyristors. The turn off the SCR whenever it is required to brought the thyristor or SCR into off state. Whereas the advantage with using GTOs is that whenever you are required to turn off the switch or bring the switch into off state, by that moment you can remove the trigger pulse. That means by applying a simple trigger pulse, injecting a pulse into the gate circuit, the thyristor or the GTO can be brought into off state. And IGBTs and MOSFETs are also self-commutating devices. It means whenever you require to make the devices to turn on, you can bring them into on state by applying a trigger pulse at the input terminal, or if you do not want to operate them, you can withdraw the application of the pulse. So these devices can be operated with the help of pulse width modulation technique. These devices can be operated with the help of pulse width modulation technique. So another name for this DC to AC inverters that make use of IGBTs, MOSFETs are also known as PWM inverters, pulse width modulated inverters. So now we see what are the applications of this DC to AC converters, that is inverters. So mainly these inverters are used in uninterruptible power supplies. So you heard the word UPS, uninterruptible power supply. If you are having any PC in your house, there you are purchasing a UPS device that can give some uh, backup power whenever the main supply is off. Second one is aircraft power supplies. The best application of these inverters is that aircraft power supplies, because we know that aircrafts will have their own generators installed in the aircraft where it is required to supply power. So that power can be supplied with the help of these inverter circuits. After that, variable speed AC motor drives. As I said, AC motors works or can run at a constant speed. So it is required to make the AC motor to operate at a different speed other than the rated speed. You need to change the speed. That variation in speed can be achieved by using a variable frequency DC to AC converter. The main and the principal application of this DC to AC converters is that supply real and reactive power to a power system. These AC to DC to AC converters are used. So by suitably changing the operating states of the switches that are connected between the input and output, it is possible for us to change the variation or change the amount of active power injected, reactive power absorbed into a power system. So that is a different story. You study in your at your postgraduate studies in electrical engineering with the heading power quality. So this is the block diagram of DC to AC inverters. So here, this is the simple, I can say that a yes system, uninterruptible power supply system. So you know that this UPS or the conventional inverter, what that you are using in your for domestic applications, is injected into the mains. So in our house, we are going to get AC voltage of 50 Hz frequency. So that AC can be converted into DC with the help of a AC to DC converter, with the help of a controlled rectifier or uncontrolled rectifier. By using the diode or by using thyristors, it is possible to obtain AC to DC conversion. After the AC to DC conversion, the ripple that was present in the output voltage or the output of the rectifier circuit can be eliminated with the help of, sorry for the interruption, మధ్యలో phone calls కాలేజీలో ఉన్నాను కరెంట్ పోయిందన్నమాట. So it is a conventional UPS block diagram, uninterruptible power supply block diagram. So that here we take supply from the source and that AC voltage is converted into a DC voltage. This can be achieved by using a phase controlled rectifier or uncontrolled rectifier. That means a rectifier circuit that may use diodes or SCR. You know that the output voltage of the AC to DC converter will contain some ripple in it. For that purpose, that ripple is to be filtered out. So the ripple that was present in the AC to DC converter is filtered out by using a capacitive filter here. So the purpose of using the capacitor here is to stabilize the input voltage or the voltage that is available across the output terminals of the AC to DC converter and stabilize the input voltage that was supplied to the. So here we are using a voltage source inverter circuit. The trigger pulses are controlled with the help of a control. So once the AC to DC to AC conversion is done, it is stepped up or stepped down to the required voltage level with the help of a transformer. After that, we are using AC filters to eliminate any unwanted frequency components that are present in the AC output voltage, so that a pure sinusoidal output voltage will be delivered to the load. The load voltage is continuously measured and is compared for the production of required gate pulses to the inverter circuit. So this is what the block diagram of DC to AC inverter. So basically, this inverter is having two kinds of configurations. Configuration is nothing but the way how the switches are arranged in the way how the switches are arranged in the circuit are known as the configuration. So based on the type of arrangement, these inverter circuits are of two types: half bridge inverters and full bridge inverter. A bridge circuit will contain, for a single phase, will contain two arms. So half bridge will contain only one arm, in which each arm contains switches. One arm will contain two switches in it. Okay. So this is the circuit diagram and arrangement of half bridge inverter supplying a resistive load. Half bridge inverter supplying a resistive load. So two switches are connected in series. S1 and S2 are the two switches. These two switches are connected in series, and two sources are connected in series, so that the load is connected between the middle point of, or the interconnected points of sources and the. So whenever the given polarity, here you are seeing the polarity of the input voltage. You are seeing the polarity of the input voltages, so that the load voltage polarity is also given such that the right side terminal of the resistor R is assumed to be positive, and left side terminal. For this given polarity, the load voltage is assumed to be positive. Load voltage is assumed to be positive. As a result of that, whenever S1 is switched on, load voltage V0 is equal to applied voltage plus voltage drop across the switch. So what happens if you take an ideal case? Under ideal circumstances, a switch S1 will have zero losses. S1 will have zero losses in it. As a result of that, what happens is load voltage V0 is equal to VDC. We suppose that the switch S1 is on for a time duration 0 less than T less than capital T by 2. The switch S1 is on for a time duration 0 less than T less than capital T by 2. So that the load voltage V0 is equal to VDC. The load voltage V0 is equal to VD. So this makes the load voltage positive. In the next half cycle, T by 2 less than T less than capital T. S1 is off, but S2 is on. Switch S1 is off and S2 is on. What happens when S2 is on? The negative terminal of the second source is connected to the positive terminal of the load. As a result of that, a negative voltage will get impressed across the load. Because of that, V0 is equal to minus VDC. V0 is equal to minus VDC. So this makes the load voltage to become negative for the time duration T by 2 less than T less than capital T. And T greater than, small t greater than or equal to capital T. Again, S1 is switched on and S2 is switched on and S2 is switched off. As a result of that, what happens? The positive terminal of the load is connected to the positive terminal of the source. This makes a positive voltage to appear across the positive voltage to appear across the load tech, so that this activity, this periodic activity will happen continuously. This periodic activity will happen continuously as t tends to infinity. Because of that, what happens is a an alternating voltage will be impressed across the terminals of the load, across the terminals of the load. So now the current I naught is equal to V naught by R. Current I naught is equal to V naught by R. So because of that, what happens is, because the load is resistive, the load current will follow the applied voltage. The load current will follow the applied. Okay.